So we're going to talk about data. This part should be a little bit easier. How do we collect data? Name me ways. Graphs. What else? Charts. Good. What else? Whoops. Tables. So graphs, tables, charts. How else? When you did a science fair project, what did you use on your board? To show your data. Pictures. And now that we have more technology, we can even use video, right? To record data because it helps look back. You can even see errors sometimes if you record everything. A lot of times we will record our lab so that way you can look through it after. And then the one that people usually forget is like journaling or daily notes. Sometimes it's not just about creating a graph or creating a table. It's jotting down information to later organize in a graph or a data chart. One of the most important things in this class is that your data is always organized. Sometimes your grade is going to be based solely on your ability to organize data, okay? So keep that in mind. Now, we're going to take it a little step further because a lot of times we don't really realize that there's a right way to graph, okay? Especially when you're doing an experiment using variables. So, what kind of graph is this? A line graph, okay? And this is a bar graph. Anybody know when you choose a line graph over a bar graph? I'm going to pause. So you guys mentioned line graphs show time, they show increases and decreases, and they show money. And as you said, they all have to do with numbers, okay? So whenever variables, your independent variable and your dependent variable are numbers, you're going to choose a line graph. If your independent variable and your dependent variable is something other than a number, so it could be one is a number and one isn't, then you will use a bar graph, okay? So in this case, we still have amounts, but then we're going to talk about fruit. So the choice for that graph would be a bar graph. When you graph, you will always set up, even if it feels odd, the independent variable on one axis and the dependent variable on the other. Anybody know which is the answers? Just by looking at the wording, it should be easy. The x-axis would be, which box is bigger, guys? Come on. Good. Independent is a longer word. The independent variable would go on the x and the dependent variable goes on the y. Always. And remember, when you're writing a hypothesis, where does the independent variable go on your hypothesis? After what? If. If I do this, that's my independent variable, then this will happen. That's my dependent variable. Oh. So what's my sixth and final step in the scientific method? You. Conclusions. Conclusions. What's your name? Lily. Lily. Conclusions. A conclusion is always going to do what? What do you do a conclusion for?
You basically explain what happened.
That's the key word right there. The big word is explain. You're going to explain if your hypothesis was what? Right or wrong. In conclusion, my hypothesis was correct. Blank, 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 blank. In conclusion, my hypothesis was incorrect. And then you're going to explain why. Why was your hypothesis correct? Why was it incorrect? Here's what you're not going to explain. You're not going to explain why no. Explain why you chose your, I'll fix it, why you chose your hypothesis. I'll make this red. You do not explain why you chose your hypothesis. You explain why was your hypothesis correct. I'll make this yes, yes, yes. And I'll make it blue. Visuals are everything. All right, so that's the 6 steps in the scientific method. Problem or observation or question. Then we do background. Then we create a hypothesis. Then we test our hypothesis, because if a hypothesis cannot be tested, we're going to have to create another one. We collect data, and then we explain our data. All of this in this class will go housed in what's called a lab report. Who's written a lab report? Okay, good. I need to know that this lab report rubric is always going to be on every lab you do. Well, not every. Any lab that I require you to write a lab report, I'm going to use the rubric to grade, okay? The rubric can fluctuate a little bit in points. Notice how I put 10 to 20, so it depends. Sometimes I want to give you 20 points for creating a good hypothesis, or sometimes I want to give you 40 points for... So the first thing on your lab report is to state your question, your problem, or the purpose of the lab. I'm going to tell you right now, Roman numeral 1, 3, and 4 are usually provided to you by me. What do you think 3 is? What do you think I'm going to provide you? What you have to do. That's 4 procedures. What else am I going to provide you? What am I going to give you so you can work on? Materials. Good. So I provide you with the problem statement or a purpose of the whole experiment. I provide you with materials, and I provide you with procedures. From those 3 things, that should give you an idea of what we're doing, and that'll lead you to create what? Hypothesis. That's Roman numeral 2. Okay? Your hypothesis or your educated guess is going to come from background information that we've already covered in class. Then, after we experiment, what are we going to collect? Data. And then we're going to draw conclusions. Now, look at the point value of conclusions. What happens if you decide that you're not going to write a conclusion for me? What's the highest grade you could get? 60. That's it. The highest grade you could get on a lab, which is 25% of your overall grade, is a 60 if you don't write one simple paragraph. I'll come back so you guys can fill in the blank. Let me just finish this video. What does your paragraph have to have? I'm breaking it down for you even further. I'm telling you, you need this, this, and this in order to earn the 40 points. What do you think is the first thing you need? Awesome. Accept or reject your hypothesis. So in conclusion, my hypothesis was incorrect. And right there, you restate that hypothesis. So your sentence is perfect. Oh, wow, I just showed you all the answers. Then you restate data, and then you explain why. Okay, so you're going to restate data. So let's say our data is a chart of numbers. Give it a sentence that explains kind of the overview. Trial 1 did this, trial 2 did this, or this many for here, an average of this. You don't necessarily have to restate every single information of data, but restating one thing is not going to cut it. I need an overview. I need to know that if I read the conclusion, I understand exactly what happened in your lab. And then explain why. I'm going to tell you again, one more time. You're going to explain why your hypothesis was accepted or rejected. What made that happen? That's the part that's going to tell me that you understand the topic, okay? If you can explain why it happened, you understand the topic. If you can't, what's the highest grade you could get? 60. No, you restated your hypothesis, you restated data, but your explanation is not good. An 80. Let's say your explanation is okay, but it's not perfect. You could get an 85, 90, 95. Not trying is the worst, okay? So this last slide is writing a conclusion. If we go back here, I want you to remember that in a hypothesis, there should be an if-then statement. Make sure to add that to your rubric, okay? This is how I expect your lab reports to be. If you start your problem, okay, and right underneath, you will do Roman numeral 1 problem. Let's say you don't remember the Roman numerals. I don't care. Just title it problem purpose, underline it, and then type your problem below. Okay? Same thing. You're going to write the word hypothesis. You're going to underline it. And then your hypothesis will be below. So we'll drag this here and it should go right here. And then you write the word materials and you underline it and you list the materials. Something else is procedures need to be numerical. Always. There's a reason why procedures are numbered, and it's for you to follow them.